Okay, so this problem is a little bit different than ones we've looked at before. So let's walk through and see what's important. The problem says, assume Clark and Lana leave Smallville Stadium from the same point at the same time. If Clark runs south, so south is down, at 4 miles per hour and Lana runs west at 3 miles per hour, how fast will the distance between Clark and Lana be changing at 10 hours? So here we have a right triangle. We know that dc dt, so the rate at which Clark is moving, is 4 miles per hour, and dl dt is 3 miles per hour. Okay, and we'll call this d for distance. How fast will the distance between Clark and Lana be changing at 10 hours? So we need to know the distance, so the derivative of the distance with respect to time at t equals 10. So we need to look at a couple different parts of this. The one thing that we haven't pointed out that we always look for in these problems is we look for what we find, we look for what we know, and we need an equation. Since we have a right triangle, the best way to go is using the Pythagorean theorem. So that means that d squared equals L squared plus C squared. And this is what we'll end up taking the derivative of and plugging everything in to. There are a couple things that we still need to figure out that we have the numbers to figure out. We just don't have explicitly stated. Some other given things we can figure out after 10 hours how far Lana has gone. And we can figure out after 10 hours how far Clark has gone. We use that 10 hours and we look at how fast they're going. So if Clark has been moving at 4 miles per hour times 10 hours, that means that Clark has gone 4 miles. Similarly, if we look at Lana, if she's moving at 3 miles per hour for 10 hours, that means she has gone 30 miles. That's not just 4, that's 40. So let's change that. Good job if you caught that. Sorry about that. Okay, so we have Lana who's gone 30 miles and Clark who's gone 40 miles. We know how fast they're going, and now we need to figure out, we would need this distance. So we can use this equation before we take the derivative to figure out the distance. So d squared is L squared, so that is 30 squared, plus C squared, which is 40 squared. So d squared is 900 plus 1600, which is 2500. That's d squared, but we need d, so the square root of that is 50. So if we look back at this equation, let's take the derivative to figure out our answer. So first, we are going to have 2d dd over dt equals 2l dl over dt plus 2c dc over dt. And we can plug information in. We have dc dt, we have dl dt, we have c, we have l, and we have d. So the only thing that's left is d dt, and that's what we're solving for anyways. So we have 2 times 50 dd dt equals 2 times 30 times 3 plus 2 times 40 times 4. So we have 100 dd dt equals 180 plus 320. Extend that a little bit. So we have 100 dd dt is equal to 500, and we need to divide both sides by 100. So finally, we have dd dt is 5. And we need some units of measure, so the distance between them, that's a straight line that we're measuring. So we are looking at miles per hour. And there's our answer.